So our speaker for the second talk is Gijs Molenaar, who describes himself as a software composer, music brewer, beer flyer, and drone programmer. And he will be talking to us about maintaining a PLC communication library without owning a PLC.
Thanks, Neil. My name is Gijs. Many people struggle with that name. It's Dutch. It's not Afrikaans, so please don't speak Afrikaans to me. Those conversations don't last very long usually. I've been called Gijs, all that kind of stuff. I came here by Uber, and before, when I took an Uber, the driver was like, Gijs? Why did they call me Gijs? And I got a speech synthesizer, always called me Gijs or Gigs. And so they improved the situation. Now I don't know what happened, but now if I arrive here, it is arrive. So they don't speak out my name anymore. I don't know why. Maybe they realize that they're doing it wrong. They have a confidence estimation or something. So I'm here to talk about Snap7. I have a little consultancy company, Python-snap7. It's a bit dormant now because I work at Spotify. But the website is still there with my info and what I've done in history. So my name is Gijs. I'm Dutch. I'm from Amsterdam. I lived in Cape Town for a while. Did some work for Sarajevo, but in the time it was still called SKSA. I find it much easier to pronounce. I did a PhD at Rhodes. I'm a rodent in astrophysics, but now I'm at Spotify. And I haven't given a talk in a while. I like giving talks, but I was just too busy working for Spotify. And I wanted to give a talk about Spotify, what we do with Python and stuff like that. But it's quite a complex vetting process. I get approval from my manager and his manager and his manager. A lot of people need to look at the slides. So I decided not to talk about that. So sorry. But I was digging in my history to see if I could find an interesting story. So I thought Snap7. I've never talked about that. So a little bit more about me and to give a bit more context how this all happened. I was living in Amsterdam. I did a master in artificial intelligence, and while I was doing this master, I did all kind of computer vision things. Things like I made a hand pose controller for Ableton Live, but this was all pre-deep learning. And so back then, those things were quite complex. You had to build your own data reduction pipeline for color modeling and stuff like that. And but things were looking quite good. I finished my master. I did that project. I got a job with a startup doing facial expression recognition. I had some couple of side hustles. I worked for MonetDB, which is a database product coming from CWI. That's a group that's a research institute in Amsterdam that also created Python, actually. So, and yesterday there was a lightning talk about DuckDB. DuckDB also comes from the same research group. So I worked on a Python API for MonetDB, and I did things with, for example, EduVPN. Probably many of you know EduRoam, that if you're a student, you get this Wi-Fi with EduRoam account. And the cool thing is with EduRoam that if you go, for example, to the Netherlands or some other country, and you open your laptop, and you're logged in with your EduRoam account, and you have free Wi-Fi. So the same thing is with EduVPN. Not many people know about that. Check it out if you're looking for a VPN and you have an EduRoam account. I worked on the Linux client, but that's already a while ago. So things were going reasonably well, but then something bad happened. And this is a bit of a link to the mental health talk we saw yesterday. I fell on my head. I fell from reasonably high backwards, from 2-3 meters. I fell on my back. I broke all my ribs. I had a whiplash. I had a fracture in my skull. I lost hearing on one side, and I had a quite serious brain trauma. So the cool thing in the Netherlands is that if you pay 25 euros, you go to the hospital and you can get your full medical dossier. So I got a pile of DVDs with all my MRI scans and CT scans, and I started looking what's actually wrong, because I had tinnitus in the night. I had problems sleeping, and so I tried to find all these things that were broken. So I'm not a medical specialist, but these are 3D renders of all the data that I got. So So I was like, oh, is this maybe something? Or so also like I was always dizzy all the time. So I found these I don't know what the name is, but these rings that have liquids in them. So these are for measuring rotation and things like that. So I found them and I found some cracks, but I don't know if again I don't want to self-diagnose things. But I had great fun with all this data. Um, but it took about 2 years to really start to recover from all this, right? Like so for really, I remember after 2 years, I had a moment like, hey, there was a day that I didn't constantly was confronted with the limitations that this incident gave to me. So I didn't have any like massive headaches or dizzy or overwhelmed by audio or light or people. Like I had so much problem focusing with groups of people to multiple people talking at the same time. With that, also multitasking, and so like work was just very hard. Being among people in a setting where you had to focus and so I lost that job. I applied for all kind of jobs, and coming from I had a master's degree in AI, and the future was booming, and suddenly was unemployable. Um, so until I went to a Python meetup, and I was talking to an astronomer, and he said, I'm working on this radio telescope in the Netherlands, and we're looking for a software engineer, and why don't you come by the university, and we'll explain you more about it. I'm like, all right, that sounds cool. I have no idea what that is. So I went to the University of Amsterdam, and I started talking with the professor, and he assumed it was a job interview. And I was just getting information. And he was like, oh, yeah, congrats. You're the only one who came. So you have the job. So like, oh, cool. Suddenly I had a job. So I told the professor, like, look, I have this problem with my brain, so I cannot work, full time. I need to have a bit of a more like a reduced program or something. It's like, oh, fine, like we'll figure something out. So I signed the contract for initially, I think it was 2 times 4 hours a week, and he was like, yeah, no, this is great. We don't have that much money anyway. And then I joined the sort of recovery program, slowly increased the amount of hours I was working. Meanwhile, learning everything about radio astronomy, physics, and I could follow courses. I could gym at the university. So this was great. This was the perfect thing. I would say it saved my life almost. So then 2 years later, I went to a conference in South Africa, and I didn't know anything about SKA, and I met a crazy Russian professor there. And he was like, oh, why don't you come work for us? I'm hearing what you guys have been doing, and we can use a guy like you. So before I know, I was in South Africa for half a year. And so this is a picture from the old SKA office looking out on Devil's Peak. I love that office. I really miss it. So, but suddenly I was in South Africa working there. So I was seconded to South Africa. I kept my university job, but half of the year I would be in South Africa and doing similar stuff for radio for SK. But I'm getting a bit distracted, so I'm here to talk about Snap7. I want to tell you a bit how that happened and where we are now, and how to actually build a community around an open source project. So how that all began was actually also during my recovery. I didn't have any job, but I finished studying, and I had another classmate that was finished studying, and he somehow managed to get an assignment with a edible oil terminal in Rotterdam. So this is in Rotterdam, and these are all silos filled with oils, from canola oil and olive oil and whatever. And ships come, they pump it out, and some need to be heated because they're not liquid at room temperature, and it needs to be pressure controlled, and you need to clean it. And so they had a whole complex central operation room, all software based, but that was really old, was really a lot of manual work, and they wanted to replace it with something more modern and safer. So then he got involved, and he was rewriting this whole control software alone. And he was working already on it for a long time, and they wanted to see results. So, and he was struggling a bit. So he said, he came to me. He's like, "Oh, can you help me out?" And together we started looking into this, and at the core, this is what we had to do is interface with PLC. So PLC is a programmable logic controller, and it's basically a computer that has been ruggedized, so it made more robust against dusty, warm environments. It has very robust operations. If you shut it down and you turn it on again very quickly, it will start up again. Just run the program. It's a real-time operating system. It's fast, and it has all kind of I/O modules which you can easily program, so you can let it respond to certain inputs coming in, like the temperature went up, so you flip a switch and do something about it. It's used in an environment where high reliability is super important, but also it needs to be super simple to be programmed. So yeah, think about a super reliable Raspberry Pi, if you know what is a Raspberry Pi. So they're used everywhere, all around the world, in all countries, in auto manufacturing, in power grids, elevators in buildings, all this kind of stuff. So I stole this slide this morning from this talk, which is a very interesting talk about Gijs talking about how they hacked the Siemens PLC. So I recommend to read that, to watch that video also. But very typical for these PLCs is that you program them in this kind of fashion. So non-programming specialists are supposed to be able to interact with the PLC and create this kind of ladder logic schemas. So this is for a bottle filler machine where you have certain inputs triggering a signal, and then there's a timer, and then you take an action, for example. So it's supposed to be super simple. So if we look at the global market share, then Siemens is the global winner, and they produce a specific PLC that you can communicate with the S7 protocols, and that's what this talk is about. So they also have super expensive software suites that you can use as an interface, and it's all licensed and proprietary, and with these things, engineers can control a large power plant, for example. This is a picture that I got from my wife. She was in Mozambique. She's in water, and she said, like, oh, this is also like some Siemens thing. She doesn't know what it is, but this was a panel interacting with all the Siemens controllers there for a water purification thing. And I think a funny thing here is that in Portuguese, apparently you call a pump a bamba. Anyway, step 7. So we were very lucky because there was an Italian man, I forgot his name, he reverse engineered the whole S7 protocol and made a C++ library out of this, and he called it snap7, open sourced it, put it online, ported it to all kind of platforms, and this was really a lifesaver for us. Basically, you know, we could just interface our existing Python software now with the PLCs. And what's even better, what he also did, is that he implemented a PLC emulator in the library. So you can just start a server, and it pretends to be a PLC, and we could start programming against it. So, and this is great for unit testing and online community building, right? Oh yeah, so I think the internet's probably not good enough. So this is one of the few things that were saved from the work that we're doing. So this is actually the panel that he built, and the operation for that whole plant, and there's things opening and sensors being activated. I don't know what would be. So, but then, basically, yeah, we got fired. So we don't know why. I didn't get directly fired, only indirectly, but Stefan got fired. They were like, okay, sorry, this is just taking too long. I don't know what the reason was, but one day to the other, they said, okay, we stopped this. They paid well, but they just didn't want to use the software in the end. So then we have all this software that we developed, and we didn't really know what to do with it. So we just put it on GitHub. Like we asked them, like, hey, what do you want with this software? And it's like, we have no interest. You can do whatever you want with it. So we just dumped it on GitHub and put an MIT license on it. And the reasoning was that we didn't want to make the work go to waste, right? Like we put on all these hours, and maybe somebody else could use it. But we just left it as is, and we were hoping that maybe somebody would contact us to hire us to improve it. Right? Like we're the expert now, so maybe there was some money to be made here. But then the contributions started to drip in. So the people all around the world started using this thing. And suddenly we got pull requests. Oh, that's nice. So, and over time, this got more and more. I mean, it's not a massive amount. It's quite a specialized library. You know, it's not a web framework or anything. But we got things from Germany, from Argentina, young people, young kids from India that wanted to have experience with open source and improve the test suite. All those like little things started happening. So that was great. And also the questions came. So a lot of I still get like emails like once a week for people that have a little problem. I don't really have time to answer these things anymore, and often they're just in the documentation. I think it would be a great feature actually if GitHub at some point allows you to train a LLM with some RAG or something to answer these questions, but many are just in the documentation. So, I wouldn't be surprised if they do this in the next 1 or 2 years, right? Like, or the other way around, where like many of these questions are answered and they could be added to the documentation. So I think we're not that far away from automating this process. So, and it would save us a lot of time. So, point is that just putting this software online is actually a great business card. And I got invited a couple of times by people working in the automotive industry or doing consultancy there, also in Cape Town here or in Amsterdam, and in mining. Like, oh, we're actually using your library, and we run into some issues, and like maybe can help us. In the end, no business came from this, but in the end, I was sitting there with these people, and it opens doors to have an open source library in this kind of context. So. But also for me, it was a great learning opportunity. Maintaining this thing, these questions come in, and in my spare time, I sometimes would have a look at it. And what I also didn't expect, and only realized later, it's also great for coding interviews. So, for example, with Spotify, when you apply for the job there, you have a first conversation that you can steer a little bit. And they're like, oh, can you show us your skills? Like, you're like, oh, I have actually a couple of open source libraries. You want to look at one, and you show it on GitHub, and you go through the code, and they're like, oh, why did you do this? And since you wrote the code yourself, you can explain everything. So this was great for career progression also in that context. So yeah, for me, all the things that I learned maintaining this library was like, first of all, using C types. It was a DLL shared object. So we had to figure out how that works. Then we also wanted to keep it cross-platform. So how to do that on all the operating systems. We migrated it from Python to 3. Like how does the Py project TOML file work? At some point we switched to binary wheels. 80% of the questions coming in were problems installing the thing because you had to download the snap7 package and take the DLL and drag it to your Windows system folder, or you had to install a Debian package or that kind of stuff. But the introduction of the wheel format, that was not required anymore. You can just bundle the SO in there. So how do you do that? How do you do that on GitHub Actions? How do you do that for every platform? We all had to figure that out, and we did. So we use GitHub Actions. That was fun, using Docker containers. We cross-compile stuff to ARM, from Intel to no, that's it. And we introduced Python typing. That was also a new thing. Now the whole thing is Python typed. We use all the fancy tools, Black, Rough, PyPy, that kind of stuff. And recently we ported it to Apple M1. And then at some point I got this email from the supply chain risk manager at NASA. And they're like, oh, whoa. And they're like, oh, yeah, I'm doing a risk assessment of your software. And it looks like you have all these contributions going in. I go, oh, wow, that's cool. NASA's just my software. So, but I don't know what department. I didn't really want to elaborate on that. But I also was wondering, like, why do they care so much about where people come from? And then, it's obviously like supply chain. So they're worried about China, probably, and Russia. And but I said to them, like, I don't know. I don't get a copy of their passports if people, I look at the quality of the code. So that's really what I replied to that. It's like, look, I really don't know. The only thing I know is that the code is good. I looked at the code and it looks fine to me. No buffer overflows or anything. It's also just a thin wrapper around DLL. Like what could be in there. But yeah, then I started thinking a little bit more. And just before I started making these slides here, who knows what this is? Yes. Yes, it's a PLC. Well done. But it's a very specific PLC being used by Iran to enrich uranium. And and I found this funny video. So somebody made a Stuxnet virus simulator on YouTube, and they used that PLC, and that PLC speaks S7. And like for you, if you don't know what Stuxnet is, it was this worm, and it would just go around the world, stay dormant, but only it would activate if it was came in touch with a Windows machine that had that step 7 software installed, and then once it would detect it, it would get activated, and it would reprogram the PLC to just change the program slightly so the frequencies that these things would, I don't know how you enrich uranium, but it's rotating, and it would rotate in a different frequency, so it would vibrate and the thing would break. But they also installed a DLL into the step 7 software that it would not visualize that change. So the program would still look the same. You get this ladder logic thing. And so yeah, that's Stuxnet. This is basically a tech, right? So super sophisticated, using multiple zero-day exploits, and yeah, so it's, again, supply chain. Let me see. So yeah, I said yesterday morning I started reading, like, oh yeah, the Stuxnet, it's actually quite interesting. How did they do it? And I found this article of this guy that like writing about the modern version of this Stuxnet. Oh, interesting. Reading it, and then I go further, like, oh, he's using my library to explain how to do it. It's like, that's fine. So I mean, basically, it just shows in Python how to break a uranium enrichment factory. So that's it. So community. Right, so I think this became sort of a success without too much effort. Was we had a little contribution guide that we constantly pointed people at, because most people that come to this software actually are not very familiar with open source development and how to do a GitHub pull request and that kind of thing. So just having that written out and then saying like, oh, there's a test suite, you need to run the test suite, and then we know that it's good. That already helped a lot. So like people learned that from that again. So that's also like a reference to the teaching people how to learn themselves to learn. Just having a little contribution guide can do miracles, in my opinion. I think I still need to update it. It has been updated in a while. But yeah, obviously you also need a test suite. And we were lucky with that emulator, right? So with that emulator, we could just test all the functionality of the library. Also important, I think, is stay formal and strict, stay friendly. Like assume that people that write very broken letters have brain damage, like myself or something. Like there was something that I sort of really tried to do there, but also stay strict. So in the beginning, I was very happy, like, oh, people are using my library and they send in a pull request, but it was really bad. So like, I cannot really accept this. And sometimes people get upset. They're like, oh, it just works for me. So stay formal, stay strict, and enable others to help others. So I think that's also a good one, where we at some point had a Slack server and people could come in there and ask questions. It sort of died out. That's a bit unfortunate. But yeah, like if I don't need to help everyone, but the people in the community can help each other, that's great. And we now have this discussion page on GitHub that is also quite useful. And this is more a note for myself, like time is a precious resource. I have very little time, so I need to really plan now how I contribute to this project and how to do this in the most efficient way. So, but at the same time, we just made the 2.0 release, or I did. I was sick and I was bored, and I sat down for 2 days and I just solved all open bugs. And now I'm actually a bit sad. I feel like a kid with Christmas, and you got all this candy, you just ate all this candy, and now I have nothing to eat next week anymore. So I'm a bit of a love and hate relationship with this project. It's because it's open source. Originally, I wanted to get paid for it, but now I cannot stand it if it's not pretty and nice. So I just finished it. And there's almost no issues coming in, only questions. So I think it's sort of done. So now we're thinking, I was speaking to some of the other people working on it. So what shall we do next? So we just rewrite all in Rust, learn a bit of Rust. Or maybe drop the whole C++ code base, just port it to Python that is compatible with PyPy also. And maybe that makes it also possible to, use on MicroPython. Or reverse engineer the S7 COM plus thing, but that's illegal because it's all encrypted and, nice challenge. So, that's basically it. And I have one more thing, but I didn't really know how to fit it in, so I'm just gonna tell you. 3 to 4 meters. So I'm married to a Namibian woman. We met here in Cape Town, and they have a farm in near Windhoek. And a couple of months ago, they found this massive python there in the garden of 3 to 4 meters. And as you can see, it has something in it. And we're like, oh no, we have a little doggy, Jane, a little border terrier. And but good news was it actually was one of our guinea fowls that we had 3 and now we have 2. So I have a little video of it. So some professional guy came by to capture it, and we moved it somewhere else on the farm. So it's still alive, happy, swimming around, digesting the poor guinea fowl. Yeah. Yeah. So that's it.
Do we have any questions?
So, do people share where they use this?
So we have a couple of statistics, like the PyP stats, and they show that the library, especially if we do a new release, like all these build systems upgrade, and then we see a burst of like thousands of people downloading it. But it's very hard to say and predict. It is definitely the most used library that I made. I made a couple. And if you look at GitHub, then there's all kind of people starring it and forking. And they also try to keep track by who's using it. So they analyze the requirements file of a Python project and stuff like that. But all these numbers are quite useless and only mean something in a relative fashion, I would say, right? Like if you compare it to another open source software project, and then you sort of know the scale. And, so I don't know. It's
Hello. Thanks for the talk. Amazing talk.
Thank you for listening.
I just wanted to ask. So, is Snap7 for like Siemens? Is it compatible specifically for Siemens or other PLCs as well?
Yeah, no, it's only Siemens and even a very particular range of Siemens controllers. So the newer ones speak S7 COM plus or whatever, and they have an encrypted negotiation procedure. So this is not compatible. That's the video that I linked is actually about trying to break that. So, but there's a lot of other PLCs, and they all have their proprietary language, unfortunately. Yeah.
Over here, really cool. I was telling my daughter that one of my first jobs was actually working on a very similar PLC, doing water processing, like your wife took a picture of. My questions are both related. One, what does Siemens think about this? Do you speak to them? Do you not talk to them? And the second one is, how have you tried to get paid for this? Like, what ways have you tried in terms of making it easier to contribute and make it sustainable?
I've never heard anything from Siemens, and I never spoken to them. I actually don't know. Probably they don't like it, but at the same time they like it. Like it improves the usability of their software. The thing really was that I never needed to earn money from this because I had other things going on, and this was just a nice open source project to keep alive and as a business card. Sorry, the second question was. Yeah. Yeah. I put up a sponsor button, and I think I got $20 in 10 years. So yeah, I mean, it's making the world a better place. Like it's maybe something will come from it. Also that's why I'm giving this talk. Also, I don't know what's going to happen in the next couple of years. Now people know about it. They maybe people will click on my video and like, oh, you're that guy. Yeah. Oh yeah, sure. Yeah, I mean, we can have a beer or something. Yeah. Oh, okay. A wine.
Right. Are there any further questions? Right. Okay, well, thank the speaker.
Thank you.